Alright, I thought I'd fill out that last playlist with that same problem with a 45 meter span cable with the first load of 10 at 15 meters going down when it had depressed the cable 10 meters. So I'm going to show you how that's sketched in Sketchup. In full knowledge, you can do it in AutoCAD as well. So I'm going to let you kind of figure out how to do the AutoCAD aspects of this as you learn to use them as a great vector engine. I'm going to set this to parallel projection. I'm going to then show you how relative components are stuck in SketchUp. I'm going to begin here with a line. I type L. Don't even have to hit the space bar. I get there. And now I can go ahead and use the, if you notice to the left right over here, I'm using a symbol that looks like it is a less than. I'm going to go 15 in the X minus 10 in the Y. I'm sorry, 15 in the X, 0 in the Y, and minus 10 in the Z. And that was relative there. And that's as far as I can go. Right now I'm just going to kind of finish that up there and hit an escape here. I'm going to now just go right across from here to do the straight end. I'm going to go across there. I can tab over and say 45 meters. And at this point, I'm going to go ahead and turn off the axes. So what we have here is we know we have some then unknown. I'm just going to make this is kind of an unknown, and then eventually back up to the endpoint there. This unknown, however, I'm going to go ahead right like that, and I'm going to go ahead and copy that over 15. So I'm hitting, I grab my thing, I grab that, holding the control key, I start moving it over here, and I type 15. So that in effect is where I wanted my structure to end, and so this little piece here, right, I won't need that in the end to come to the end there. So I'm going to kind of just play around here, take that. If you notice there, I can hold the inference here. I'm going to hold the shift key now once I get that inference, and I can go ahead and get that to there. You can't do the kind of grip editing in this program that you can in others, but there you kind of have the general constraints, what we have here. And if you remember, anything to the right of this structure is unknown. We had a force going down from here. I'm going to put it down at 10. All right, that was what was causing that structure to deform. We don't need this anymore. And this one down here, we know it was going to be down at some other angle. Now I'll point out here that the reality is you know this, but you do not know this. Do not let your eye fail you. So right now I'm going to go here, and I know this was 5 going down. I'm going to tab and say 5, and I don't have a good ability to do layering on this until later, so I'm just going to leave that as it is. So I'll make the assumption that what we've got here is our cable going from here to here, and what we need now is to solve for the reactions. And once again, remember, it's going to be force times. I'll show you how construction lines work in this program, and that of course is to go ahead and put in a construction line, which is sometimes easily done by just kind of doing this. So that construction line is going straight up. I'll do another one here, construction line. So I've got a couple construction lines there, and in fact we remember that force times distance plus force times distance equals force times distance. And so we had 10 times 15 plus 5 times 30 has to be reacted at over here. And so we ended up with a reaction here of, I'm going to go ahead and hit the pause here, forgetting the calculator again. I'll just do it in my head, I guess. If you remember, it was something like 8.66 because it was 10 times 15. This is 150. It essentially was the area of this rectangle here. Go ahead and then again that one there, and it has to be reacted to by a rectangle going back the other way. So I'm going to hit the pause here and then figure out my reactions, and then come back from there and show you how you go about using to figure out what exactly is this geometry and what your check will be. I'm hitting pause. Alright, it turned out that that reaction, bad memory, was 6.66. You see as I'm taking this up here, and then I can type in 6.66. In reality, we then have 8.33. I'll go ahead and put that force up here, tape it up here, 8.33. Of course, 8.33 and 6.66 is there. Now what we have here is we have something we can start doing some geometry with by using whatever engine we know how. In fact, this I've got to control. We know that is that in that direction, and we know that in the end it has to have a component going in this direction, so this vector matches it. So I'm going to take that in, because we've got that direction was given by the geometry, which means that my component in this direction will be that. And you see it closes it up. I go ahead and erase out the middle, erase that out, and if I go ahead and then label this right here, it should give me the length as 12.5, which is what we remember is our horizontal component. So what we have now is we have that 12.5 here. I'm going to go ahead and move that over, hitting the control key to copy there. There's my two components there. And even though this isn't necessarily, well, we should probably do it, we're going to go ahead and draft out over here what is in effect 12.5. And in that, we now know what the direction of this cable going down is going to be, it turns out, by going ahead and drafting a more or less the reaction force. If you notice here, it's going to try to find that parallel to that and parallel to that. And so we know in full reality that's what it should be when it comes down, so we can get rid of this, erase it, and then extend that force down. Now you'll figure out the math of this, but the graphics of that is of course just as correct. And if you remember here, that was the unknown. So I'm going to go ahead and erase that, and erase that, and even erase that, and we'll check whether this indeed turns out to be true. As I draft this up to here, right, remember we got that from knowledge that basically this has no component in the x direction, none of these cables, so if there's 12.5 going this way, there's got to be 12.5 going that way. We solve for each reaction by doing sum of the moments. You see that it's a little bit more on this side than on the other. This shape that you see here in front of you is the shape of the moment diagram. But now let's see, in fact, if we can figure out what the tension is in this cable. Well, let's see. Well, we know we're going to go ahead and take this 10 down. We know that's the case, so we're going to go ahead and grab, using the control key, I'll just do this off on the side. We know that's the case, and we also know that, in fact, if the reaction is pulling back on this cable, then it's also pulling all the way through the cable, so we know in terms of our star free body diagram, we also have a force here. And so we have, basically, if we think we're acting right at this point there, we have that down, that one over, and so this other one has to act back. Well, how can we do that? Well, we know it goes down this way. We can now use our rule of adding vectors tip to tail. I'll go ahead and bring that one down here. Right? And of course, I'm going to erase this one out. And we know that in effect, by the time we do that, we have to have a force that takes us back to 0, so that goes from there to there. Now we can take that one and double check that is in fact what we know, and we can go ahead and hit here and erase. We can label that up with our little bar there. 12.606 is what we guess it is. Now we can take it over here and just make sure that its geometry is what we expect it to be by going the other way, and in fact you see it is. And so that is a graphic method using Sketchup and showing a couple different tools, just letting you realize that it is worth playing around with this for all kinds of different reasons, but I guess I can take the last minute here and show you one of the reasons why. It's pretty easy now to go through and do all kinds of things in this program. Amongst others, we can go ahead and fill this in here. Didn't quite work. Edit, undo. As I draw a line in this program, it should close up if I did all my drafting correct, and it's not. So it's not closing that up, that face right there. I guess it is, which means I can push it out and do all kinds of different stuff. So that's just a quick one-off on how you go about using graphics to do the cables. As a review, what we did was we solved for the reactions in the y direction. We use the geometry of one side's cable as it was given. We have to have one point to solve what the reaction in the horizontal direction is, and we put that to both sides, and then we use the geometry of the cable system to figure out where the other points are. That will work in more than one or two forces. You can do that with a series of things on a cable, and you start to approximate then the catenary or the parabola as you do a lot more. Thanks for listening. That'll be the last post in how to do cables.